Electron configuration. Earlier we learned about the nucleus, proton, neutron. Now we focus on the electron. One rule: electrons are not randomly allocated. So in case they are not just jumbling around, but they have certain rule. In Bohr's model, electrons they move around in energy level, or we call shell. How is this work? The work is they bring on the level 1, you will have the maximum number 2 electron. Level 2, maximum 8 electron. Level 3, 8. And level 4, 18 electron. Now see. Maximum number 2 electron it can hold. Second shell, 8 electron. Third shell, 8. Fourth shell, I have not shown on this graph. So when we placing electron, keep in mind you always fill the inner shell first. So you fill the first inner shell first. When the inner shell fill, you fill the next level. When this level fill, you fill the next level. When this level fill, you fill the next level, and so on. So placing the inner level first, then the second shell, and then the third, and then the fourth, then the fifth, and so on. Now I show you on how it shows on the periodic table. On the periodic table, now let's look closely. They divide into period, the horizontal period, and the vertical we call group. And now I'm going to select the first 4 periods to demonstrate this rule. Now let's look. Here you can see I'm talking about the shell with many circles. Now let's look. On the period 1, you will have only 1 shell. Period 2, 2 shell. Period 3, 3 shell. Period 4, 4 shell. So on the period 1, you can hold maximum 2 electrons. Period 2, first shell, 2 electrons. Second shell, remember, second shell, 8 electrons. Period 3, first shell, 2, second shell, 8, third shell, 8. Period 4, 2 electrons, 8 electrons, 8 electrons, 18 electrons on the shell. Now let's demonstrate. Let's look on to the period 1. Hydrogen. Look on here. Hydrogen have 1 proton. 1 proton. So how many electrons be? So must be 1 electron. The second one, helium, 2. So how many electrons? Remember, proton number must equal to electron number. So must be 2 electrons. So this is easy. Now look onto the period 2. Period 2, let's look on lithium. Lithium, the top number 3, means you have 3 protons. You must have 3 electrons. How is this 3 electron distribute? Inner shell first. First shell, 2 electrons. 1 more electron left. Go to the next shell. Try another one. Beryllium, top, you have 4 protons, so you must have 4 electrons. Fill the inner shell first, 2 electrons, and 2 more to fill the next shell. Now go to group 3. So you have on the top, you say boron, 5. So you have 5 electrons. How does it feel? The first shell first, 2 electrons. How many left? 3 more. Then the remaining go to the second shell. 3 electrons. Carbon 6. So inner shell 2. Outside shell remaining 4. Nitrogen 7. Inner shell 2. Remaining on the next shell when you fill 5. And you can see oxygen 8. So inner shell 2 fully filled, next shell remaining 6. Fluorine, same rule, inner shell, outer shell, total 9. Neon, inner shell, outer shell, total 10. That's how it works. Now look on to the period 3. Period 3 will have 3 shells. So inner shell fill first, second shell fill second, then remaining fill the last. Now you have 11 proton. You must have 11 electron. How does it fill? So first shell take up 2, second shell 8. How many now? That is 10. 1 more to fill next shell, the third shell. So the third shell have only 1. Magnesium 12 proton must have 12 electron. How this 12 electron distribute? First shell first 2, second shell total 8. How many now? You got 10. 2 more remaining. So the next shell maximum you can hold 2. And you can see the rest as group 3. Aluminium, first shell, second shell, third shell. Next, silicon, first shell, second shell, third shell. Group 5, first shell, second shell, third shell, and so on the rule. Now let's go on to the period 4. Now period 4 you have 4 shells. So now this have not on the first one. 4 shells, potassium K have 19 electrons. How this 19 electron distribute? So first shell fill first, the inner shell fill first. 2, and then next shell 8. How many now? Total 10. So the next shell another 8. How many now? Total 18. So you need 1 more to fill the outer shell. 1. So now total 19. Calcium 20 electron. How does it how does it distribute? First shell, second shell, third shell, final the last shell. And student, please keep this in mind about how the electron distribute. One day, teacher will ask you, okay, I randomly select an atom, phosphate, P. Can you show me how the electron distribute? You will have to know first shell 2, second shell 8, total number 10, and the remaining 5 will go on to the third shell. So if I randomly pick up any atom, then you have to know this electron shell distribution rule. This is called electron configuration of the Bohr model. Thank you.